Assalamu alaikum wa rahmatullah. I am Abderrahmane Benhamza, a PhD student in Department of Mechanical Engineering at University of Ouargla. And today, in the occasion of the first international conference on the sustainable energy and advanced materials, I am going to present my research work entitled Drawing Uniformity Analysis of an Indirect Solar Dryer with Solar Chimney using Computational Fluid Dynamics. Firstly, I would like to thank the conference community for organizing this interesting and useful conference. Secondly, I would like to acknowledge the Department of Mechanical Engineering at University of Ouargla for PhD scholarship and supporting this research work. Also, my deepest thanks go to Lenreza Laboratory for hosting me during doing this work. In this presentation, we will talk about the background of study, objectives, methodology, the results, then the conclusion. So the first station of our presentation is the background. Recently, Ouargla City is one of the top producers of agri-food products in Algeria. At the beginning of harvest season, the plentiful fruits and vegetables provide food and income for farming families all across this region. And in this season, products are so plentiful, in fact, that every year supply outpaces demand. And smallholder farmers are left with vegetables that cannot be sold in local markets once harvested. And this is exactly what farmers suffers from due to the poor processing methods and shortage of storage facilities. Actually, open sun drying is one of the oldest preservation techniques of agricultural products. But in open sun drying, the products are affected by external calamities such as rain, insects, and animals. Furthermore, the quality of the dried products is far below the desired standards. So solar dryers could be the best alternative for open sun drying because the products are protected from UV, and also this type of drying minimizes drying time from weeks to hours. In this study, we have used the indirect solar dryers to find the best design of solar dryers that ensure uniform drying, enhance the air velocity, and also reach the drying air temperature suitable for agri-food products. The main steps followed to solve this issue were an experimental study in Lenreza laboratory using the indirect type solar dryer, then obtaining a validated CFD model by comparing the experimental studies with the numerical ones. Then to enhance the uniformity inside the solar dryer using the validated CFD model. The experiments have been carried out in an indirect type solar dryer, which contains a solar air collector, drying chamber, and chimney. The food inside the drying chamber is heated passively via the hot air supplied by solar air collector, not by direct exposure to sunlight. In the numerical simulation of the CFD model, the boundary conditions were gauge pressure equal to 0 Pascal in the inlet and the outlet of the solar dryer. Moreover, since the experimental setup is thermally well insulated by polystyrene, the heat loss from the solar dryer edges was neglected. Therefore, a diabatical condition was adopted to all these boundary walls. To validate the reliability of the CFD model, the results of numerical modeling are compared with those obtained experimentally. A good agreement between the predicted and the experimental values is observed, with The main relative error ranged between 3.5 and 8.6%. In this slide, we present the temperature distribution for the solar dryer with ordinary chimney and the solar dryer with solar chimney. The aim of adding or replacing ordinary chimney by solar chimney is to enhance the air velocity inside the drying chamber. By presenting the temperature distribution inside both drying chambers, it is observed that the maximum drying temperature was 326 for this design and 319 for the original design. These are the velocity fields for both solar dryer designs. We can observe that in the solar dryer with ordinary chimney, the velocity ranged between 0.1 and 2.6. However, in the solar dryer with solar chimney, the velocity ranged between 0.2 to 2.4. So there is an increase in air velocity in all this region from 0.1 to 0.243, as we can see here. For best analysis of the CAD results, image processing technique has been applied to select the best design that ensures more uniform temperature distribution and velocity distribution inside the solar dryer chamber. The obtained results show that the temperature uniformity in the solar dryer with ordinary chimney is more uniform by 37% compared to the indirect solar dryer with solar chimney. However, the velocity uniformity in this solar dryer is more uniform than this one. Conclusions and perspectives. The solar dryers are the best alternative solution to avoid open sun drying limitations. Results from the numerical model established herein demonstrates reasonable agreement with the results obtained from experimental investigation. The presented work is a contribution to find the optimal design of solar dryer. Replacing the ordinary chimney with a solar chimney improves drying air temperature by 7 degrees, but the temperature uniformity was better by 37% for the solar dryer with ordinary chimney. Finally, exergy analysis and techno-economic studies will be a good proposition for the next step to develop the current study. And thank you for your attention.